Hi, welcome to Lab 3. In this video, I will be explaining the map function and tuple transformation. I will also explain what a stateful function is and how they are used with the Python API. In this lesson, you'll learn about modifying tuples with the map and flat map functions. You'll also learn about stateful functions and some of their applications. Sometimes, you will want to change something about the tuples that are on your stream. Maybe you want to access and change one of the tuple's attributes. It could be that you'd like to add more attributes to a tuple, or that you want to split one tuple into multiple. Perhaps you want to erase some information from your tuple. These are all ways of transforming or modifying tuples. When you want to modify the content or type of a tuple in any way, including splitting tuples, you must first define a function that will modify a tuple as desired. Then you can call it with one of the following. The map function is the generic function for transformations that produce a single tuple. It takes as input a callable object that takes a single tuple as an argument and returns either 0 or 1 tuple. The flat map function works similarly, but it can return 0 or more tuples as an iterable. It is used for returning multiple tuples, for example, splitting a coordinate pair into x and y components. In the illustration shown, the map function is invoked on the yellow stream and is passed a function called color to blue. The resulting tuples come out blue after their transformation. In this lab, you will be using the map function to anonymize tuples by hashing certain identifying patient information. What if your application needs to draw information from multiple tuples on the same stream, for example, to compute their sum? It would have to hold past tuples in memory. This type of function is called a stateful function. Stateful functions keep track of data that has already been processed, saving the state across calls to the function. When you define a certain number of tuples that you are concurrently keeping state of, this is called a window. Callable objects that maintain stateful data can be passed to any stream's operation. In this example, the stateful function is summing up the values of the past 6 tuples and outputting their sums to a new stream. This is simply one type of useful application of stateful functions. Others could include, for example, taking averages or real-time detection of anomalies in a set of data. In this lab, you will extend your application. It will continue to get its data from the patient simulator, but now it will hash that data to anonymize it before filtering. You will also introduce a stateful function to keep track of the moving average heart rate from the last 10 readings. Finally, your application will print out its data as it has been doing since Lab 1. To summarize, the only new parts that you're introducing in this lab are the data anonymization and the average calculator. Concerning your patient data, there are several important fields that you will have to make use of in this lab: patient ID, location ID, and value. Patient ID is the patient's number, location ID is the number of the bed that they were assigned, and value is the value of the reading. The syntax for accessing each of these fields is shown for your reference. That's everything you need to get started with Lab 3. By the end of this lab, you will have a fully functioning application. As always, there will be a solution video to follow this lab. Then you can move on to Lab 4, which is all about visualizing the data that comes out of your application. Good luck!